Have you ever wanted to build your very own Q&A engine? Maybe you wanted to be able to pass through a body of text and get answers from it by querying in natural language. Well, that's exactly what we're going to be going through in this video. We'll be taking a raw body of text and we'll be passing it through a BERT-based deep learning model to be able to surface answers. And we'll be integrating it inside of a full-blown web app which is being built on Anvil, the sponsor of today's video. But more about them later. Let's take a deeper look as to what we'll be going through. So this video is going to be very much focused on building a full stack web app, one that's based on top of a BERT-based deep learning model for question and answering. This is almost akin to having your very own search engine at your fingertips. Now we're going to build it in a dynamic way so we can pass through the text that we want to search through and pass through the questions, but you could definitely just point this to your own body of text and surface that as your own little mini search engine. So in terms of what we're going to be focused on, first things first is we are going to take a look at what dependencies we're going to need. We're then going to set up our Roberta model. So this is going to come from Hugging Face Transformers. We're then going to hook it up to Anvil and build our full stack web app. So we can actually surface this as a web application for other users to try out. Ready to do it? Let's get to it.
Alrighty, so first things first, in terms of building our Q&A model, we're going to need to go on ahead and install some dependencies. Then we're going to go on ahead and load our model. And for this, we are going to be using this model over here. So the Roberta base for Q&A model from Hugging Face Transformers. Everyone knows that I love Hugging Face. It is a great library and works really, really well. So we're going to be using that. Then we are going to hook up our deep learning script to Anvil. Now this is really, really cool. So you can actually connect your Jupyter server to an Anvil server and actually run your deep learning models like that. It's really, really cool how it works. Regardless of the fact that it's sponsored by these guys, I think Anvil is absolutely a brilliant platform. And again, I'm probably going to feature this in a bunch more tutorials. So do stay tuned. So once we've hooked it up to the Anvil server, we are going to set up a callable function. So we're going to effectively make our deep learning model from our Jupyter Notebook hooked up to our Anvil app so that we have a dynamic Q&A engine, really. Okay, so first things first, we need to go on ahead and install some dependencies. Now, the first dependency that we are going to need is PyTorch. So because the Hugging Face Transformers model is based on PyTorch, we are going to go on ahead and install it. I'm just grabbing my little trackpad thing. All right, so to install PyTorch, we just need to go to pytorch.org, and then from there you can hit install, and then it'll walk you through this little wizard here. So we're going to choose a stable version, Windows, because I'm on a Windows machine. Hit pip. We're going to install for Python, and I'm using CUDA 11 dot something, so I'm going to choose 11.3. So you can choose your different options here depending on how you actually want to go on about and install this. So if you wanted to install on Mac or Linux, you can choose those options there. We're going to choose Windows. We're going to install with pip and for Python and for CUDA. So we can grab this line here and paste it into our Jupyter Notebook with an exclamation mark at the front. And just get rid of that 3 and run that. So that will go on ahead and install PyTorch. So you can see that it has successfully installed, no errors. Again, it's probably going to take a little bit longer when you do it because you are doing it from scratch. Okay, so now that that is done, the next thing that we need to go on ahead and do is install Transformers. So Transformers is going to be what allows us to use our Roberta base model. Now, again, this is reasonably straightforward to actually get up and running. We can actually just copy down the code from here, but I'm going to walk you through it in a little bit more detail. Okay, so what we need to do is install Transformers. So this is PyTorch installed. Let's add some comments. PyTorch install. We are then going to install Transformers. And this one is just a pip install Transformers. Boom. And that is now installed. Cool. So we've now gone and successfully completed step 1, install our dependency. So we've installed PyTorch. That's all done and dusted. And we have installed Transformers. The next thing that we need to go on ahead and do is load up this Roberta model that we were just mentioning. So down here, this is going to be how we actually go about using this. So we can actually even just copy this code and bring it in. So I'm going to include a link to this as well. Now, rather than copying it, I'm actually going to walk you through it. So that gives you a little bit more of an idea as to how this is all going to work. All right, so first up, we've got to import some stuff from Transformers. And this is really to do with the tokenizers, the pipeline, and the model itself. So let's go ahead and import these dependencies, and then we'll take a look at what we've wrote. Okay, so we've gone and written one line of code there, and we've imported three things. So first up, from transformers, import auto model for question answering, auto tokenizer, pipeline. Okay, so let's break this down. So first up, we need the auto model for question answering as the backend pipeline, or the backend model for our pipeline, which is over here. So this is going to be what actually allows us to load up our Roberta model. Then we've got our tokenizer. So this is, again, in the background, what allows us to actually convert our natural language to an actual set of tokens. So think of a sentence as just a set of words. And then what we do is we take that set of words and we convert them to individual identifiers or tokens. That's exactly what that does there. Now, in this example up here, you can't actually see the imports, but when you do scroll down a little bit further, you can see that it is bringing in all of those dependencies right there. Okay, for now, we know that we've gone written from transformers, auto model for question answering, auto tokenizer, pipeline. So we're mainly going to be using pipeline, but these two are needed as a dependency in the background as well. So this is going to load our model. This is going to bring in our tokenizer. So again, converts sentences or words into individual identifiers, and the pipeline is what actually allows us to use the Roberta model. Cool. Next thing that we need to do is actually go on and download our model and instantiate it inside of our notebook. So let's go on ahead and do that. Okay, so that is our pipeline now instantiated. So I've gone and written a single line of code there. So let's actually add some comments here. So this is importing the dependencies for the BERT model. Well, technically, it's the Roberta model. And you can choose the different types of models that you want on Hugging Face. This is one of the things I really, really do like about it. So say, for example, you wanted a question and answering model, you could do that. Say, for example, you wanted a summarization model or a text classification model or a text gen model, you can do that. So in this particular case, we wanted a Q&A model. The most popular one in this case is the one that we're using. So DeepSet Roberta Base Squad 2. So again, you open that up and you've got instructions on how to use it, which is exactly what we are doing here. Okay, so we've gone and created our pipeline. So Hugging Face has this concept of pipeline. So really basic natural language tasks, you can use it as a pipeline. So I've written NLP equals pipeline. So again, we're using the Hugging Face Transformers pipeline. And the task that we are completing is question answering. So we're going to be passing through context, so a body of text, and we're going to be asking a question of that context, and we're going to get a returned result. So we're actually going to try this out on some Wikipedia articles. So we'll be able to plug in a Wikipedia article, ask a question of it, and you'll get a response back. Okay, so we're in NLP equals pipeline, and then the first positional argument is question dash answering. So it's just a string. And then we're just defining what model and tokenizer we want to use as part of that pipeline. So we're overriding the defaults in this particular case. So I've written model equals, and then it's just the name of that model that I've pulled down from over here. So it's DeepSet / Roberta -base -squad -2. So model equals, and then again, it's another string. So DeepSet / Roberta -base -squad 2, and then we'll set our tokenizer as well. So DeepSet / Roberta -base -squad 2. Cool. So that is our natural language pipeline now set up. Now, if you're doing this for the first time, it is going to download the model. It might take a little bit of time depending on the speed of your internet, but once you've gone and downloaded it into your environment, you should be good to go. Cool. So let's add a comment here. So this is creating the Q&A pipeline. And then let's actually go on ahead and test it out. So we can actually pass through, or in order to actually use this model, we need to pass through a dictionary. So we're going to create a dictionary, and then we're going to call it Q, or we'll just call it question set. And then to this dictionary, we need to pass through two things. So we need to pass through a question, and we need to pass through some context. Coolio. All right. And then, so let's say, for example, so I really like using Wikipedia articles because I think it's great and you can sort of validate relatively easily. So we're going to type in or search for, I don't know, Spider-Man. Let's try Spider-Man. Yeah. Cool. All right. And then we're going to grab this block of text here. And let's actually create, so context. So I'm just going to create a new multi-line string. Paste that in there. And we're going to set our context variable inside of our dictionary equal to what you can see over here. So this, let's just call it Wikipedia text. All right, so our context is going to be our Wikipedia text, and then we've got to ask it a question. So let's say, who is Peter? Actually, rather than who is Peter Parker, who is Spider-Man? And we need a comma there. All right, so we've just got a dictionary. So what have we gone and done there? So we've gone and created a multi-line string. So I've written Wikipedia underscore text equals triple quotation mark, and then we've pasted in our Wikipedia text from there. Close our triple quotation mark, and then we've gone and passed that through to our question set dictionary. So question underscore set equals, and then squiggly braces, and then we've got two keys. So question inside of quotes, and then a colon, and then we're passing through our question so we can change this, right? So our question is, who is Spider-Man? And then I've passed through a comma, and then our next key, so context, colon, and then we've passed through our Wikipedia text. So let's just make sure that is set correctly. Cool. Okay, so now if we go and test this out in our NLP pipeline, so if we pass through our question set, there's our answer. How cool is that? So that is it actually working. Yeah, I think this is absolutely phenomenal. So we've got our score, we've got our start, so where it is in the text, and the end, where it is in the text, and that's our response. So you can see that it's actually gone and responded back, Peter Parker. So let's try another question. Who created Spider-Man? Take a look at that. So Stan Lee and artist Steve Ditko. And again, we've got a really high confidence score there, so 84.6%. So again, looking like it's actually performing reasonably well. What's another great question? Trying to think. When was Spider-Man created? (1962). Is this like, if this is for real? Take a look. So he first appeared in the anthology comic book. Let's zoom in on this because it's probably tiny. He first appeared in the anthology comic book Amazing Fantasy number 15 in August 1962. How sick is that? As if that is not awesome. So I think this model is absolutely fantastic. Who is Spider-Man's enemy? We've got to escape out of that. I don't know if we've actually got that in our... Oh, take a look! Dr. Octopus, the Green Goblin, and Venom. So it's actually picked it up from there. So, and foes such as Dr. Octopus, the Green Goblin, and Venom. Guys, as if that is not awesome. Okay, so that is our Q&A model now up and running. So we've gone and installed our dependencies. We've gone and loaded up our model. So remember, this is our context, or our corpus. Let's call it contextual text, or background, or corpus. This is how we define our question set. And then we can actually go and run it through our NLP pipeline, which is pretty cool, right? But we want to take this one step further, right? So we actually want to hook it up and build a web app out of it. This is where Anvil is going to come in handy.
Once again, thanks to today's sponsor, Anvil. Anvil is a platform for building full stack web apps entirely in Python. It makes it easy to build and deploy full stack machine learning and data science applications, and the Anvil framework is open source. You can use the platform for free and upgrade if you want to use custom domains and server-side libraries. Plus, it's also entirely free for education. Head on over to anvil.works/Nicholas Renaud. The link will be in the description below to get started. Plus, we're also going to be using it throughout this tutorial. Back to it.
So the cool thing about Anvil is that you can actually build full stack web apps relatively easily. I was amazed at how quickly this is actually able to get up and running. So all you need to do is go to anvil.works, which will take you to this page. And again, it's all free, so you can upgrade if you want to go custom domains and server-side Python, but you can actually get started with this for free. So if you're doing data science stuff, deep learning stuff, really, really quick to get started. So we're going to go hit start building. And you'll probably have to sign up. You pass through, so it's just a username, password, or you can use your Google account like I think I have. And you should be able to create a template app. So we'll give that a sec. Cool. So once Anvil is loaded up, you should be taken to a page that looks a little bit like this. So this assumes you've gone and logged in and created an account. Again, it's reasonably straightforward to get up and running, but this should be your home screen. Now, what we're going to go on ahead and do is create a new blank app, which is what you can see over here. So this is a new blank app. So we're going to do exactly that. So let's create a blank app. And again, the cool thing is that you can choose what type of theme you want to use. So whether or not you want to use Material, Classic, which I think looks like Bootstrap, and some other different types of themes. We're just going to use Material Design to begin with because it looks pretty clean. And then we should be able to get up and running to build our app. Now, this is all relatively straightforward to actually do. So you've got sort of a whole bunch of drag and drop areas. And the nice thing is that you hook them up using Python. So let's say, for example, we wanted to create a title. So we've got drop title here. So I can go and grab this title element, just drop it there, and just type in, ask me a question. Oh, let's actually make it so deep learning. Let's just call it ask me a question. Cool. And we're just going to call this. So over here, we're just going to name our elements. So over here, I've just gone, let's go reselect that. So we're just going to call this title. And then you've got this sort of landing area here that you can see that is being pseudo highlighted when I go and tab over it. So what I want to do is I want to add in 3 different sections. So we'll actually add a button. So first up, we're going to have a button here, actually. Not that button. I want this one, the highlighted button, because that one looks cooler. And right down here, we can actually align it to the right. And we are going to call this, we'll just say submit. Actually, we'll say ask question. So what we're going to do is we're going to configure this so that when we click this question over here, we can actually go and run something. And that is exactly by double clicking what I've gone into. So if you double click into it, it's going to take you to the code section. If you go back to design, you're back to this area. Okay, so we've gone and set up our title and we've just gone and dragged a element over to that drag and drop area. We've gone and dragged in a button. So again, I've just grabbed this button and dragged that here. So if I wanted to add more, do that relatively easily. Now, the next thing that I want to do is add in an area to pass through our context. Now, you don't need to do this. So say, for example, you wanted to have all of your text-based data stored inside of your notebook. You could do that as well. But again, we want to make it highly interactive. So users can pass through their own Wikipedia text and actually test this out. So for now, what we're going to do is we're going to drag this text area element. So over on the right-hand side where we can go to our toolbox, I'm just going to grab this text element or text area element and bring it over to here. And so this is going to be our text input. So I'm going to rename this element. So over here under our properties, under name, I'm just going to select into that and call it input text. Right, so this is going to be the input text that we pass through to our context over here, right? And again, this is all going to be dynamic. So you're actually going to be able to repoint what it is that you want it to look at. So that's going to be our input text. That's where our user will enter some input text. Then we want an area where a user can ask a question. So we're just going to use a text box element for that, what you can see over here. But there's a whole bunch of other elements. Again, I haven't tested all of these out, but there's a ton. So I'm going to grab this and bring that there. And this is going to be, so again, in our properties. So if you select it, it'll open up your properties. And over on the right-hand side, I'm just going to change the name of that to be question text. And you can see here that when I'm naming each one of these elements, it's defining it as self.questionText. This means that that element will be able to be referenced inside of our code as self.questionText. So when I write my Python script, I just need to write in self.questionText, and it's going to grab whatever's inside of that element, right? Pretty cool. There's one more element that we need to add here, and that is our response. So effectively the answer. So again, what do we want? So do we want just some basic text, rich text? Let's try rich text. I didn't try that before. No, let's not use rich text. I haven't tried it. I don't know what that's going to look like. I think I just used a label. Did I use a label? I can't remember. Let's add it. Let's leave it as label for now. I think what I did is I selected the label and then I made it a little bit bigger. Let's make it a subheading. I think I did use rich text. Let's try that. Yeah, okay. So select rich text and then let's make it a font size of 22. No, this should be font size of 22 here. So that will be a little bit bigger. So again, you can choose what type of elements you want to use. I think originally I used rich text. You can add in a label. There's hyperlinks, so on and so forth. So this is going to be our response. So we are going to select that element and we're going to call that an answer text. So what's going to happen is a user enters text here. They enter their question here, hit ask question, and the answer should appear here from our deep learning model. Okay, so let's go on ahead and start coding this up. So if we go and run it, right now there's not going to be anything happening, but let's type it, call it Q&A engine. We go and run. This is our app actually running. And again, it's not hooked up to anything at the moment, but we could grab our Wikipedia text for all of this, paste it in there, could drag that open, make it a little bit bigger and go, what is Peter or Spider-Man's name? Who is Spider-Man? It asked me a question. Right now, it's not going to do anything because we haven't actually configured that. But you can see that is our template already sort of set up, right? Now, if we wanted to publish this, we could go and publish it and you'll have this link that you can actually go on ahead and use. But for now, we're going to stop our app because we actually got to design the plumbing now. So as of right now, we've got our shell, but we actually need to design or hook this up into our Jupyter Notebook. Now, this is exactly what we're going to do here. So first things first, we need to go and install a new dependency, and this is going to allow us to connect to the Anvil server. So let's go on ahead and do this and we'll be able to test it out. Okay, so that is our main dependency now installed, and this is the Anvil uplink capability. So this actually allows us to hook up our Jupyter Notebook to Anvil. So I've written !pip install Anvil-uplink, and that is going to allow us to hook in to our Q&A engine app up here. So for now, we can minimize that. And now what we actually need to do is we actually need to connect to our Anvil server. So to do that, we can use Anvil. Or we actually need to import it. So import anvil.server. And then we can hook up to it. So we can run anvil.server.connect. And to this, we need to pass through, let's just enter some blank text for now. So we need to pass through our Anvil token, or I think it's effectively a token. Now, this allows us to hook in this Jupyter Notebook into this app. Now, this is actually relatively straightforward. So you just hit the gear up here. So right up here, hit that gear, and then hit uplink, which you can see there. And then all we need to do is select enable the Anvil server uplink, and you'll get this code here. So this is a privileged connection code. So again, if you try using the one that I'm showing here, it's probably not going to work because it's going to be the code for my application, and I'll reset it eventually after the app. But once you go through and connect it up, you'll actually be able to hook in your Jupyter Notebook into this. And there is also a bunch of tutorials on how to do this for Colab as well. So if you're taking a look at that, again, you can do it. So I'm going to copy this and paste it over here. And all things holding equal, we're now hooked up. So you can see that we've connected to our Anvil uplink. Our WebSocket is open. So our server, our Jupyter server can now connect with our Anvil app. Then what we need to do is set up a callable function. So that is, let's take a look at what we've done now. So we've installed our dependencies, we've loaded up our model, we've connected our Anvil, or we've set up our Anvil uplink. Now what we need to do is actually set up a callable function. So we need to have a function that Anvil can call to talk to our Jupyter Notebook, and that our Jupyter Notebook can use to hook up to our NLP model that we had up here. So that's exactly what we're going to do. So first up, we need to define a decorator, and this tells us that it's going to be an Anvil callable function. So let's do this. Cool, that is our decorator now defined. So this tells the app, or tells the Jupyter server that this is a Anvil callable function. And to do that, I've written the symbol, anvil.server.callable, and then we can just define a function down here. So we could write def, I don't know, what are we going to call it? Answer questions, and then pass through our question text. and our context text. And then inside of this function here, we can just do all of, sorry, we had a slash there. Inside of this function here, we can just do all of our regular NLP based stuff. So we are really just going to take in, we need to define a question set. Oh, let's close that. Question set. And our question is just going to be our question text from our function, which is this over here. Sorry, this should be text. And our context is just going to be our context text, again, from our function. So what we've written now is at anvil.server.callable, and then we define our function that we want to run. The function that is going to do our NLP. And in order to do that, I've written def answer underscore question. So we're defining a new function. So def answer underscore questions. And then to that, we're going to accept two positional arguments. Question underscore text, and then comma context underscore text. So this question text is just going to be the text that we're passing through over here. This context text is going to be our body, right? Which is just going to be similar to what we had as our Wikipedia text. Cool. So we take our question set, and then we convert that into a dictionary. The next thing that we need to do, so I'm just going to add some comments, convert this to a dictionary. Then we are going to run it through the NLP pipeline. So we can call NLP and then pass through question set. And then we're going to store the results of that inside of a variable called res. And we'll just call it results. Let's actually be reasonable and name some verbose variables. So then what we're doing is we're calling our NLP model, which we had from over here. And because this is running on the same Jupyter server, we can actually just grab that. So we've got our NLP function or our NLP method. And then to that, we're going to be passing through this question set over here. So the next line is results equals NLP, and then to that we are passing through our question set. Now keep in mind that when we get these responses, we are getting our dictionary back. Really all we want is this text. So let me show you how to extract that. So if I type in results equals NLP question set, type in results, what we're getting back is a dictionary. So if I take a look at the type, you can see it's just a dictionary, right? To get that value back, all we need to do is access it as a key. So if I grab just the answer key, I'm going to get back the exact result that I want. And that is exactly what we're going to return back as part of our answer questions function. So I'm going to type in return results to answer answers. It's answer. And then we're going to grab the answer key. Right? So this function now can actually be called by our Anvil server. So I think let's try it out as well. So answers questions. And if we put in so we'll make this our question text. And then we want our context, which was our Wikipedia, right? So you can see that our function is successfully returning back Dr. Octopus. This is just a warning. What's that saying? It's a deprecation warning. It's perfectly fine. Don't worry. You can ignore that for now. So what we're getting back is Dr. Octopus, the Green Goblin, and Venom. So our result, so if we actually store this inside of a variable, so Anvil result equals that. And then if I type in Anvil result, boom. So that is the text that we're going to go on ahead and set to our rich text area over here. So we're actually going to be calling this now from within our Anvil app. Now, you're probably thinking, Nick, how on earth do we actually go on about doing this? Well, keep in mind, we've already set up our framework for our app. So we've got our title header, we've got our button, we've got our input text, our question text, and our answer text. Now we need to pay close attention to each one of these elements, right? So this variable over here, or the variable that's going to allow us to access the text from our input, is going to be self.input_text.text. Likewise, it's going to be self.question_text.text. And our answer text, which is what we're going to set, is going to be self.answerText or answer_text.text. Cool. Okay, but how do we actually attach this function or this, our answer questions function to a specific action inside of our application? Well, you just need to double click on the element that you want to trigger that particular function. So in this particular case, we want it to be connected to our ask question button. So if I double click that, we are going to switch into our code mode, which you can see over here. So this little tab allows us to switch between our form and our actual code. Now, from here, this is where we can start to hook up all of our good stuff. So I'm just going to zoom in on that so you can see that a little bit better. So in this region here, we can actually define what we want to happen when that button is clicked. And that is exactly what it says there. So this method is called when the button is clicked. So we can actually get rid of everything that's in there for now. And what we want to do is we want to get a couple of variables. So we want to get our question text, and we're going to set that equal to self.questionText.text. So this, and it looks like there's autocomplete, which is pretty cool as well. So this is going to be the text that we're accessing from this over here. So that is self.questionText, and then to get the actual text itself, it is .text. The other nice thing is that you've actually got these code snippets. So say, for example, I wanted to go and specify how to get my input text, right? I don't need to remember that I need to write self.question_text.text. Let's create a new variable for now. So I'm going to call it input text. And we're going to set that equal to right over here. We can actually just access this code snippet. So this is our element. So self.input_text. We want to get the text back. And you can see it actually advises us how to actually go on ahead and set it. Now, we don't want to set it in this case. We just want to grab it. So we can just copy this and paste it here. So we've now successfully got the question text from our app. We've got the input text from our app. Now, remember, what we're going to want to do is we're going to want to set the text for our rich text down the bottom, which was called, I think it was the answer text, right? That's answer text, yeah. So right down here, we're going to grab the self.answerText, and we want the text again. I wonder whether or not we should have used a rich text element. So this is setting it slightly differently. Let's actually convert this back to a text element. Yeah, I don't want to do this. So rather than using rich text, let's actually use normal text. And I'm going to set this to answer text. So all I'm doing here is I'm converting it back from rich text to answer text. You might be able to use it, but I don't think I used it originally. So in order to be consistent, I'm going to do this. All right. And then we're going to change the layout. How do we take a look at the appearance? That's what we want. Here we go. All right, so we want it to be, we'll leave it the alignment the same. We'll leave the font the same. We're just going to make it bigger. Make it 24. Okay. So all I've gone and done there is I've just gone and changed the answer to, change this bottom element to be from rich text to just a regular label. And again, you could play around with this. There's probably a whole bunch of elements which are more reasonable, but in this case, this is going to work. Okay, so we've gone and set that. We've gone and reset our label or our element name. Now, if we go back into here, what we're going to do, if we actually go and take a look at our self.answerText, you've now got a text element. So before, when I had rich text, it was setting content. We don't necessarily want to use a rich text element in this particular case. Lesson learned. We are going to grab this text and we are going to set it to eventually the answer that we get. Answer from the NLP model. Cool. Okay. So that is the base layout now done, right? So we've successfully grabbed our question text, we've grabbed our input text, and we have some way to go and set our answer text down here. What we now need to go on ahead and do is somehow call this answer questions function that we've gone and defined inside of our Jupyter Notebook. And that is exactly what we're going to go on ahead and do. Okay, now the nice thing about this is that it's actually reasonably straightforward. So we can call anvil.server, and then what we want to do is we want to call the function that we've actually gone and defined. So in this particular case, it's going to be answer_questions. So anvil.server. We want it to be call and then the name of the function. So it's going to be answer_questions, and then we can pass through our arguments. So the full line is anvil.server.call. It's not the name of the function. We call, and then we pass through the positional arguments, which in this case are going to be our question text and our context text. So question text and then context text. Wait, no, it's not called context text. It'll be our input text over here. Okay, I think that's good. And then let me zoom out so we can actually see this. So we are then going to name this, that's a little bit small, isn't it? So let's call this results and set that equal to that. The full line is results equals anvil.server.call. To that, we're passing through answer underscore questions, which is going to be the name of the function that we've defined inside of our Jupyter Notebook. And then we are passing through the 2 positional arguments that our original model is expecting. So if I zoom out a little, that is the full line. So results equals anvil.server.call. And then we're passing through the name of the function that we had from up here. And then we are passing through the positional arguments in order. In order is really, really important. So we first pass through question text, then context text. Question text, and then input text. We could rename this context text if we really wanted to. And that is going to return back our result. So this is just, let's add some comments. So this is access. So access the values from the app. Call the Jupyter Notebook uplink method. And then there's one last thing that we really need to do. We need to go and reset this answer text element to what we just pulled in from over here. So this will be show the result to the user. And then so rather than having this this string here which just says answer from the NLP model, we want to replace this with result. Let's actually call this result. It shouldn't be results. Okay, I think that looks good. Let's take a step back. So what have we done? So we've gone and installed our dependencies for the NLP stuff. We've gone and defined our pipeline. We've gone and tested it out using the NLP pipeline, set up our Anvil uplink. We've then gone and uplink is such a cool word. We've then gone and defined our callable function. And remember, in order to do that, we just pass through our decorator. So at anvil.server.callable, which goes before our function. And then we've gone and designed our layout. And remember, we've got a text area over there, a text box, and a label. So rather we had this as rich text, we went and changed it back. Also got a button over here. And if we go into our code, which is just available by selecting that. Oh, there you go. You can expand it. It's much better. So then what we've gone and done is we've gone and called anvil.server.call, which is going to call this method, passing through our question text, which is the first parameter, passing through the context text, which is our second parameter or second argument. And that is being accessed from the values that we've got inside of our form. And then the last thing that we're doing is we're actually setting, so right down here, we're actually setting our answer text, which is that final element. We're setting that text equal to the result that we get back from our function from our Jupyter Notebook. So I think this is it done. All right, let's run this. So if we go and hit run, and if we copy a Spiderman text from Wikipedia, make this a little bit bigger so we can see it. Let me zoom out. And if we say, who is Spider-Man in our text box down the bottom, take a look. It's returned back Peter Parker. How sick is that? So that is our app actually working. So we've gone and successfully hooked up all of our elements, and we've done effectively our plumbing. And remember, so let's actually test out some other examples. So who is Spider-Man? When was Spider-Man created? When was Spider-Man created? 1962. So you can see that down there. Let's make this bigger so you can see it. All right, so what are some other questions that we can go on ahead and ask? Let's make sure you can see this. This looks good. Where did Peter, does it say where he went to school? Who is Spider-Man's uncle? Ben Parker. How sick is that? Let's try some other text. So, Lewis Hamilton, my boy. I'm going to copy this, paste it into our Q&A engine. Who is Lewis Hamilton? Ask a question. Schumacher. All right, maybe not the greatest question. Let's say, who was Lewis Carl Davidson? It's hilarious that it said Schumacher. Oh god, it's probably not the greatest in this particular. Okay, so keep saying Schumacher. What does Lewis Hamilton do? Okay, so it's gone and returned. He's a British racing driver. A little bit better there. So clearly didn't like who is Lewis Hamilton. What type of cars does Lewis Hamilton drive? Let's see if it picks up Formula One or Mercedes. Hybrid. Okay, so it's picked up that he's driving hybrid F1 cars. Okay, so maybe it doesn't like the Lewis Hamilton text. What's another? Oh, performed reasonably well, apart from the fact it called Lewis Hamilton Schumacher. But trying to think, what's something else that's popular at the moment? NFTs. Wikipedia. Need some more text. Let's grab this description area over here. What is a NFT? A unit of data stored on a digital ledger. Hey, there you go. What does NFT stand for? A unit of data. So it's not changing in that particular case. Trying to find another question we can ask. I don't actually know much about NFTs. All right, probably a bad example. I don't know what questions to ask. All right, let's think of something else. What's in the news? All right, so that's just saying NFTs, machine learning. Yeah, let's actually just use machine learning. This is very meta now. We're asking machine learning what machine learning is. What is machine learning? Let me zoom in so you can see that my head's not blocking it. So it's gone and returned computer algorithms. Oh, my head's not blocking it. So computer algorithms that can improve automatically through experience and by the use of data. Cool. How does machine learning work? This will be interesting. Through experience and by the use of data. I'd say that's pretty much correct. I mean, it's doing pretty well. Okay, and that is our Anvil Q&A app, which is powered by Roberta in the background through Hugging Face Transformers. Pretty cool, right? So again, relatively straightforward to get up and running, or at least I think so. And again, as per usual, all the code's going to be available in the description below. Before we do that, let's quickly take a look at what we did, because we did do a lot. So first up, we went and installed our dependencies. We loaded up our model. Remember, this pipeline line is super important. We then went and defined a question set and passed that to our NLP pipeline, which gave us our answers. We built our server uplink to be able to hook up to Anvil, and then we built our callable function. And then through Anvil, so if I stop our app, we've also got the ability to design our layout, write up our code, which is exactly what you can see here, and then design our format. And if we want to go and run our code, we just need to hit run. And then that is our app up and running. And again, you can just copy in some text. What is machine learning? Ask a question. Boom, computer algorithms that can improve automatically through experience and by the use of data. One last thing that I actually wanted to show you. So that's a wrap on what we've done. But if you wanted to go on ahead and publish this app, right up here in this top corner, you can see that it says publish. So if we go and publish it, we can now go and share it via a private link. So if I go and copy this link, I can now actually share this application with people, right? So if I go and paste in my machine learning text, Say, what is machine learning? Hit ask a question. Boom, take a look at that. It's now running. We can even go and share it via public link. So again, in this case, we don't need to actually go and define anything else. And we hit apply. So let's copy this link. We've now got a public link to our Anvil app. How sick is that? Again, super easy to use. I'm definitely going to be using this more in the future. But if we go and paste in our text, what is machine learning? Boom, it's working. Super straightforward. Hopefully you guys have enjoyed this tutorial. And again, all the code's going to be available in the description below. And I'll also share the code that we had for our Anvil app so that you can take a look at that as well. Thanks again for tuning in, guys. Peace.
Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a big thumbs up, hit subscribe, and click that bell. And once again, thank you so much to today's sponsor, Anvil. They're an absolutely amazing company, and they allow you to build full stack web apps with just a couple of lines of Python, as you saw in this video. Again, I'm going to include all the code inside of a GitHub repository in the description below so you can pick this up and get started with it yourself. Thanks again for tuning in. Peace.